we found a guess, and now we're going to clear all variables and clear all. I'm going to define some some variables, which we can say are constant, symbols, whatever you want to call them. So sims, that's going to be a and b and t. And then what I'm going to do is I'm going to define my guess x of p of t, I said is a times the cosine of 2 times t plus b times the sine of 2 times t. And then once we have that, I wanted to output just so I check that it is correct. And then once we have that, what are we going to do? Well, now I'm going to define the second derivative and the first. I really don't need the first unless I want to check the first solution, which I do for part A. So let's just say x of p of t, x of p1 of t is going to be equal to the derivative of x of p with respect to t, the first derivative. And here I'm going to say the second derivative, and I'm going to put this over here. Okay, so now that we have this, what are we going to do? Well, now, and we can even check that I wrote it correctly if we let it output. Now I'm going to put it back into my original equation. So checking, and we had two different ones. Checking, well, I'll check part A first. So for part A, I know they said don't solve it, but let's just check. So if C is 5 and K is 4, let's just define those here. Defining the initial conditions. C is 5 and K is 4. Now if C is 5 and K is 4, then we're going to have the initial model, which is going to be xp2 plus C times xp1 plus K times xp, and all of that should be equal to, and I really want it to be equal to 12 times the cosine of 2 times t. So we press Control Enter here, and we get this answer. So now we can solve for a and b. So we match the coefficients. So here 10b needs to be equal to 12. So 10 times b needs to be equal to 12. And then here minus 10 times a needs to be equal to 0. Equal to 0. Okay, so now we solve here. We want to solve for a and b. So we really don't even need the solver. We can look at it by hand. And we want this to be at a sol, b sol. Press Control Enter. We want to actually put a comma in there, so he's gonna, okay, it actually worked out anyway. Okay, so these are our two things. So then we would redefine the solution. Now let's try it with the values that they told us for part B. So that is C0 and K4. So what are we going to have now? I think this one's not going to be valid anymore. We'll have to relook at it from here, because we're just going to have this. These are the derivatives. And now we put it here, and we just get that there's 0, and this is interesting. We get, this is 0, but actually we need to get some value for xp1 and xp2. xp2 is the derivative of xp1. So let's see. What are we doing wrong? C here is going to cancel this out, but this K times xp should be staying. And so let's try maybe just hard coding the values. So this one and 4, and this shouldn't be here anymore. Control Enter. These we don't need anymore. Okay, we get this. This is interesting because let's look at this. If I have this and I'm multiplying xp times 4, then these all cancel out. So the left-hand side cancels out. And so we get that this is not a good guess because this might not necessarily be true. So there's some linear dependence there. So we need to go back to the drawing board, and we will do that in, what's this? Part A. This was part A, part B2. We'll do that in part B3. See you there.